a little bit about myself. I'm a newbie to this forum, so it's great to see these productive discussions around AOSP and how people are dealing with AOSP problems in the industry, in the open source community. It's a lot of fun. So a little bit about myself. Um, I have been part of the open source community for more than 13 years, being a official Lineage OS maintainer. Um, I maintained two devices, one called Sprout, which was a first MediaTek device to get a official Cyanogen mod port. I think like, it still remains a truth where MediaTek devices are still difficult to bring up when it comes to doing AOSP. You debug a lot, you go through the logs, and even then you hit those blockers where, just because of the vendor binaries, you cannot get a open source variant of operating system running. So that's my background on Lineage OS, and I have worked with Sony devices, HTC devices in the past decade. Then I joined Esper. I've been, I think several of you might know about Esper, the best MDM on Android. So I've been with Esper for almost a decade, and I'm now setting on to start my own startup, which is Logcat.ai. The problem space, I think it's very clear about how do we debug Android OS at scale. So that's what I wanted to tackle on. So let me talk a little bit about how do we debug Android OS today. So I think most of you might have worked with Logcat in several capacities, and when you look at the Logcat, that the whole point of looking at the Logcat is to see what's wrong, how things are going, observing the stability of the operating system, and so many different purposes. But when something is wrong, what do you do? What do we do currently? Right now, we rely on these basic search tools like grep, control find, looking for certain keywords and certain clues, and then you want to trace them back to what the root cause might be of that issue. For example, system server crashing, or your real daemon crashing, or a telephony framework causing problems. So you look at these different log streams. You look at Logcat for system and application level errors. You look at the radio log if you want to go look at the telephony layer. You could look at the kernel log, which is the dmesg, to see if you want to see what's wrong with the kernel. And Android provides a bunch of other log streams through dumpsys. Like you have like dumpsys, which can dump different services within the operating system, how the device policies are, how is the surface flinger doing. So you can basically dump each of these services and their states as a part of this huge dumpsys report, which is called bug report, which is a collection of all these dumpsys streams. So looking through all of this, and the biggest problem that I had also faced myself in the past, and still continue to do, all the way before I started Logcat.ai, was the correlation. Like when you are looking at a log, what else is happening during that time? Like if you are seeing a crash, the crash is the obvious part. A crash is something where to fix. But what led to that crash? What else was happening on the device? Doing that is a very time-consuming process. It takes hours. Like sometimes it takes weeks or days to trace to a particular root cause of a problem. Especially in a enterprise background, this is even critical because you are dealing with an inflow of issues and bug tickets coming in at a very high scale. How do you triage them? How much time do you spend on each of these tickets? Now, coming for us as AOSP open source builders, we spend our own free time working on operating systems like Lineage OS, Graphene OS, and we work on those operating systems. So in this case, time is of the essence. Like if you want to move and to see what to solve the problem that we are working with at hand. The biggest thing that I also when I spoke with some of the maintainers is the learning curve. Android is evolving really fast. Every Android iteration is bringing something new in place, and you have to keep up. So when you're looking at a big Logcat, the first thing is, beyond these common keywords like ANR, fatal, and some other keywords, where do you even begin? And coming to slightly going on a tangent, how AI space is doing. Like, AI is being used to solve so many problems today. So, what if AI could help here? Like, what if AI could help, debug like a senior engineer? As you start at a particular crash and you trace it back to the root cause. Like follow different leads, one log leading to another, building those insights and learnings along the way, and provide you a report on, hey, this is what I found, and this could save you tons of time, like to get to that next phase. So it's not about just telling you what failed, but why it failed. What else was happening at the time? Um, Building correlation across timestamps, because timestamps also different from different log streams. So this particular problem space and the pain that I dealt with is what led me to build Logcat.ai. So what it does is like primarily three key product areas, like the deep research feature, the which is the most important one to talk here, which basically does exactly what I said, which is to do the autonomous multi-step investigation, where you use natural language query. Hey, my codec is crashing. These videos are not playing. So, help me trace the root cause for it. So, starting from the crash stack trace, it going back, going into like step by step, following different leads and getting you the actual root cause of what might be going wrong. So while working with since I've been part of the community, I thought to why not go even one step further. So if the root cause has been identified, you know where to look. So the system will know where to look. In that case, why not also provide suggestions on what patches you might be interested in actually fixing that? Integration with AOSP, get it, the bug tracker, get it for all these multiple known or popular operating system repositories, GitHub. It's all a big source of all the work that's being done, and it's a perfect opportunity to consolidate all of that together and present those findings. So Logcat.ai basically helps you perform the root cause analysis. And coming from the open source community, I wanted to give something back, which is why I'm also providing like a free access to the open source program to anyone who is building for any open source project. Just send us with your GitHub and what you're building, and you'll have free access to the platform, so that you can use our AI, which is trained on AOSP internals. It's different than the general purpose models that you use, like Claude, ChatGPT. They're built for everything, but they are not specialized on Android internals. They are not specialized about how do you differentiate between noise and signal when you're looking at big chunk of logs. So Logcat.ai helps in accelerating your debugging process and development process. So who is it for? I mean, like, of course, like AOSP folks like us, but OEMs, Android automotive builders, and which is why, like I mentioned about the USB CAN controller, was because the entire correlation problem is big in industry. Like, when they are looking at two different log streams, how do you correlate when one event happens? What was the root cause? Like, what else was happening? Bringing that visibility together. So in the Android automotive industry, it's one of the things that I've been researching. I will also be releasing a research paper that I've been writing about the debugging challenges in the Android automotive industry today. Going through this CAN bus logs, which is like thousands and thousands of signals, but on Android you only have limited visibility for those. It's one of the capabilities that's coming in, and as I mentioned, the open source program is one of the things that I wanted to talk about a little bit here. Moving to, I want to show a quick demo of what's being built. Let me share the screen. So, can you see my screen?
Yep, so good.
Great. So this is the dashboard. This is where you upload all your logs, whether it's a Logcat, whether it's a bug report, it's a dmesg. Let me walk you through a particular log, which is this is like a 10,000 logs. Um, you get the log viewer. You have the the insights, AI insights, which will tell you what are the top critical insights, what are the top high priority insights, like ordered by priority. So if you want to look at these, like not every time you'll care about every single insight here, but it's always good to know, to to see a eagle's view of what's going on with your device. So you go to logs. Let me show a crash, a particular crash in media server. Um, Go and filter by error level. This is one of the bug tickets in on LineageOS issue tracker. Where a user said they are unable to play HEVC videos, and so what I want to show, like, this is the crash, and how do you debug this? This is there's a lot of stuff going on here. So let me quickly show you a deep research report that actually I had pre-generated. Again, I can't show it live because it takes about 10 to 15 minutes to complete. So I have pre-generated a report for you guys. So this is the auto triage report. Like, this is the device. The crash has been confirmed with the media server, with the HEVC decoder. The location has been determined. Why? The root cause has been, like, this is a simple one pager on what happened. What are the affected operations? Like, video thumbnail generation and gallery apps is affected. Um, the next steps here, which tells you, like, that there is a patch in LineageOS get it, which helps suppress this problem and then fix it. So you get a reference to that particular commit. So this is the triage summary. You can go to the full report, which is a much comprehensive report of the entire investigation. So you go get the key findings. What are the critical fix? This is not here in your build. It highlights you what fix is not in your build and what you should be picking. This is a link to the get it. And there it also looks up equivalent AOSP commits, because everyone is fixing a particular issue in different way. So this brings visibility into how everyone is doing that. So similar crash has been spotted, similar signatures have been detected, and they are part of the deep research report. So this is the deep research report that gets you to the root cause analysis, like the recommendations for raw maintainers, what you should be doing, and the assessment, and finally the citations. Like what sources within the log were used to determine that particular observation. This gives you the transparency into how that investigation was done, because as you know, AI can make mistakes, and this brings you that lead on what happened behind this investigation, which every claim, how can that be validated. So this is the deep research, and there's also quick search. You can just talk about ask questions, show me top 10 issues. So yeah, it will highlight what are the top concerning things that you should be looking at in your log. So this is the Logcat. We have similar thing for dmesg. We have similar thing for bug report, and with respect to time, let me just quickly go and show 1 second a bug report view. This gives you a visibility into every subsystem, how it is performing. This is a very old bug report. Of course, things are going to be critical because it's outdated. So, but the essence is that you get to see how every major subsystem in your device is working when you actually analyze a bug report through the platform. Similar features, like you do a quick search, you do a deep research, and so on. Coming back to this, one of the things I wanted to talk about, like how do we handle the logs, like standard encryption and security protocols. I want to talk about a open source model that we recently released. It's on GitHub, on our GitHub, github.com/Logcat-AI/safeloglm. It's a 270 million parameter model, which is fine-tuned on top of Gemma's equivalent model, but specialized in scrubbing PII from your logs. So when you get logged today, I think you pretty much share it as it is. There could be a good amount of PII in there. how do you address that? And that problem had not been addressed. And this is what SafeLog LM does. It's the first initial iteration. We are improving on a continuous basis. So please go and watch that repository, and there will be more updates on that. So you can even run it locally today, pass your logs, and redact the PII that might be in the logs. That can make it safer for you to share that log with anyone. Want to quickly also highlight that like PII sometimes also is important debugging, because the PII could itself be the context of the issue that you're debugging. So you might want to use that according to your needs. We are working on a browser-based integration of this particular model, so that before they leave your system, they will be redacted before they enter Logcat.ai system. Yeah, that's I'm happy to answer any questions you guys might have. I'll be around, and please feel free to check out the open source page. And if you find this useful in your open source project, feel free to apply.
Okay, thank you very much, Varun. That's fantastic. I love the idea of something that's going to process those pesky Logcat messages for me. Aaron Gascoigne, you have something to say? Aaron, or maybe Victor?
Looks like Aaron is not answering. So my question is, you were also talking, thanks for the talk, first of all. It's quite an amazing idea. My question is, you were talking about automotive before. So automotive world, I know, usually tends to have logcats interleaved with all kinds of different logs, right? And those are in these multi-hundred megabytes or gigabytes of DLT files. Do you also support that?
Yes. So actually, like I would certainly love to send you that research paper draft. It's a work in progress. I've been talking to several automotive players in the industry, and the interleaved log data has been one of the biggest highlights. Also, like referencing external log data, like because within Android, you only get exposure for like about 250 CAN bus signals, but the CAN bus signal, the number of CAN bus signals are in thousands. So how do you bring visibility into those compared to what things are happening in the Android OS? So my goal is to address that problem, because we are building this correlation engine where it will have the ability to transcend the log formats. Like previously, we depend on log parsers, which have limitations, like not everything can get parsed. But with AI, we can transcend those limitations, and we are able to build correlation across different log streams, which will directly address the issue that you mentioned about the interleaved logs, but also the logs which are in completely different files. But they're still essential, and that still represent a particular system's functioning.
Thanks.
Cool. So Aaron asks, how much better does this work with a bug report versus a simple logcat?
That's a very good question, actually. So one of the things that I had noticed is we rely on logcat too much, meaning that logcat just paints one part of the story. Actually, I'm going to write a blog, describing this, like, why this is not the most optimal practice. You should go after a bug report. Like anything happens, you go, because bug report contains logcat, it contains dmesg, it contains dumps of every single system service on the operating system. And they bring a lot of clues. Like you're looking here, for example, if you're investigating battery drain, what's the general instinct is you go for battery stats, you investigate battery stats, you run it through historian, and you look at, but it's not as simple, because it only tells you one part of the story, like in why that happened, is that story is elsewhere, and bug report is the only diagnostic tool that actually captures the entire thing. So I would say, like, I would recommend using bug report for any investigation over Logcat.
Cool. a little while back in the chat, Vinyak asked, what kind of data did you use to train the model?
Great question. So this is trained on AOSP code today, which is available, and some of the publicly known insights around how people have solved this, and so those are the data sets. Along with that, there's a lot of internal knowledge that has gone in, like in building that, experiences, like how for the biggest one is, when you're looking at log, what's the noise, what is the noise, and what is the thing that you actually care about. So that is not documented anywhere, and that comes from the experience. So it's a fusion of so many things, and it's a work in progress. We have launched, but we are in beta, and it's evolving version over version. So
cool. Is this particularly version sensitive? I mean, do you have to retrain it on each version of Android or something, or are Logcat's messages pretty much the same across a wide range of versions?
Good question too, and the answer is yes and no. It needs to be aware of the every evolving change in the AOSP code base, but it doesn't need to go through the entire training process again. We have a way to build the diff of what changed. So we just let the model know what changed and that what parts need to be focused on. But yes, when every new Android version comes in, the training has to be updated to accommodate for that.
Cool. Alexius asked a question, or put his hand up at least.
Yeah, hi.
Hi.
My question is kind of connected to the previous one. In your demo, you showed that your model is actually, after the deep research, suggested you to apply some patches from the Lineage OS upstream. Does it mean there is a way to connect some other origins, for example, Google source, and check the newer Android tags for the fixes potentially, or how it works?
Yes, so you can actually connect your proprietary code base to, like, if you have something locally that, that's not out there, but you would want Logcat.ai to reference it, you can integrate that. So that's part of the, the on-prem offering that we are thinking about, working with enterprises who actually are, care about the proprietary code and AI sensitivity and the privacy of it all. But connection of external sources will be much more open. Currently, it's limited to GitHub, couple of Gerrit sources, but we are working for a better way to integrate into other venues from where you would find insights in the investigation.
Cool. So the next question regarding privacy. You mentioned that you're working on the way to run the model completely in the browser, but currently is it working in the cloud, or how it actually works?
So right now the model is not in place. It's a work in progress. It's being done separately, so it can still be run separately, and you can redact the code, redact the logs, and upload it. And just like any other logging company, we exercise all those standard practices in storing logs, and encryption at rest, encryption in transit. We are also working to get SOC 2 compliance to bring more protections around the log sensitivity and the log privacy and all.
Cool, thanks.
Marcos, you have a question?
Yeah, so this question is probably more interesting to Lineage OS than Logcat.ai, but you mentioned and you just talked about the browser-based log redaction for the future, which sounds great. But I was wondering if you have any plans or thoughts about device-based redaction in bug reports, which might be very heavy, perhaps, but it would allow for the info to leave the device already scrubbed, right? So I don't know. I'd like to know what you think about that.
It's an idea that struck my mind, but I am been part of Lineage OS in last decade, but I'm a former Lineage OS maintainer. But I will be sure to convey your thoughts to the Lineage OS folks. I'm pretty sure we talked about it, and it is one of the possibilities. In fact, I remember there was one variant of bug report which has a sanitized flag that you could actually generate at pre-redacted logs at source. I don't think it is part of the AOSP code, but I saw that briefly somewhere. So it's not something that's brand new. I'm pretty sure someone did it. But as far as Lineage goes, I think like it probably wouldn't be me who could answer that.
Cool. So Jay Shah says, can this model tool, I guess, is this model or tool capable of running locally with no data leaving the machine and going into the cloud or for IP reasons? I mean to use it outside the browser.
So the answer is yes, and that is the on-prem offering. It's only for enterprises who actually are looking for that kind of offering, because firstly, it comes with a lot of complications as well, because you also need to host the LLM, and to host that LLM, that requires a lot of GPU power. Something it's very difficult to even host on the residential venues. So the answer is yes and no. I think like for individuals, I think it is probably best to rely on the federated models that are being hosted, just because it's just economical to do so.
Okay, thank you very much. Anybody else have any more questions for Varun? We're kind of coming towards the end of our time slot. So I'd just like to say a very big thank you to Varun for a very interesting presentation. I think there's a lot of stuff there that we all would be interested in. And yeah, I certainly will be making an application for one of the free open source accounts, at least. Since I don't actually get paid for anything, that's the only way I can do it these days. So that's fantastic.
Thanks, Chris, for having me and giving the opportunity to talk. It's amazing, and I think I'm gonna be joining going forward for every meetup.
Excellent, glad to hear it. And please encourage your. We could do with some more people from North America to kind of balance the European bias that we have here.